So today we'll be going over the M100. M100 is a two-component motor starter built into one form factor. They come in two sizes, the 0.7 amps to 9 amps and the 4.6 amps to 23 amps. These red ones will be safety. These gray ones are non-safety rated. We'll go a little bit into the differences in a little bit. These guys are great for running devices where they're turned on and then will stay running for a minute. So this is a little example where it's controlling a fan. But because of their quick connect capabilities, you can easily like disconnect the motor, connect a different motor. And now we're controlling a device like a water pump. So it's great for like pumps, fans, and conveyor belts. And any other type of go and then continue on motion. Exit spotlight. And now it's a presentation, right?
Yes.
Yeah. Okay. So we're once again going into the M100. The M100 is a electronic motor starter enhanced by with enhanced reliability and efficiency for your motor-driven systems by combining the functionality of a contactor and overload into the same form factor. The M100 has enhanced performance and reliability and improved panel footprint and reduced engineering complexity. We'll get into how it does all these in the next couple slides. So an overview of the M100. The M100 streamlines panel wiring, minimizes component and engineering complexity. This serves as a foundation for our motor control portfolio and facilitates a smart, safe, and connected enterprise. The benefits of the M100 is that there's a 78% reduction in panel space and a 56% reduction in wiring. This streamlined design of the M100 allows you to reduce wiring and panel build costs. This not only saves on material costs, but also enhances your overall operational efficiency. Supporting zero stack capability with no derating up to 50 degrees C, the M100 allows for flexibility in insulation without compromising performance. Zero stack means you can put a number of M100s touching each other in a panel without any air gap cooling them. The M100 ability to support direct online, reversing, and safety operations in the same form factor makes it a versatile and solution suitable for various operational scenarios. With quantifiable efficiency gains of up to 75% reduction in the number of components required, a 56% reduction in wiring costs, and a 78% reduction in required panel space, the M100 empowers you to take your application to the next level. Baked into the M100 is electronic overload protection on all the modules and adherence to SIL 3 PLE, which is the highest safety standard in this area. There's also phase loss detection and phase imbalance monitoring and weld detection. Baked into these red guys. You gotta be a little bit careful though for weld detection though. If you're running a single phase through the red safety contactors, they're going to, if you wire them up wrong for input versus neutral, it's going to detect a welded contact, and then it's going to not be able to run anymore. They're working on an update for this, but as of right now, be extra careful when wiring up single phase. So here's a little bit of a comparison of the standard contactor and overload compared to the M100. In the 9 amp form factor, you have over like a quarter space saving for reversing, because in the same form factor of this this 9 amp, this is both reversing and non-reversing. It just depends on the product you buy. That also goes for these 23 amps, that there's no difference in between a reversing and a non-reversing except this functionality. Also with the safety, it uses safe port off So depending on your application, you might need an extra safety contactor if you need a isolation circuit compared to something like a PowerFlex, which this behaves more similar towards using safe torque off. So once again, as you can see here, there's the safety contactors for an isolation, but it's still all the motor starters have, the M100s have safe torque off baked into them for both the gray and the red. It just changes the way that the overload trips. Then 100 creates a 78% reduction in panel space, as you can see highlighted in green here, and a 56% reduction in wiring, because you're not wiring up as many overloads to breaker to contactors and back and forth. So M100 is a smart choice for modern automation system. Incorporating M100 into existing system is a breeze with removable terminal blocks. It's actually pretty great. These terminal blocks are available in both screw and push-in types for easy installation with less wiring complexity. Here's a push-in style. As you can see, there's little tabs. It's best to use either ferruled or solid core wires for these guys. While the screw-in, it's standard. You can use threaded braided cable, and it's going to behave as you expect. Some additional features of the PCB-based electronic motor starters includes point-of-wave technology. How this technology works is there's an optimum time in order for the contacts to open and close, and that's when the current crosses through the zero line because it's alternating. Rockwell has over 40 patents on this technology, so we're not expecting any competitors in this area anytime soon. There's also zero stack, so like this with no derating. This is up to 50 degrees C. If you have a panel hotter than that, it will start derating, but 50 degrees C is pretty hot. I'm not sure if you want your components getting hotter than that. There's built-in overload, phase loss bulb detection, and phase loss bulb detection. On the top here is where you're going to input your power, and your control for the M100 is going to be 2-wire control, but you can wire this up to be 1-button control. It just depends on how you wire it. And then down here at the bottom, you'll have indication of whether or not the drive is running, whether or not the overload is blown, and then you're also going to have the ability to do remote reset. So as if you're pressing this blue button to reset the overload. And if it's a reversing contactor, this is going to be where you put a reversing pin in. So the point-of-wave technology also has enhanced energy efficiency, reliability, and durability, flexibility, a longer component life. This has expected about 1 million cycles before it's going to die, and reduce thermals. So it's not going to get as hot compared to, say, a solid state contactor or a normal contactor, because there's going to be less arc inside of them. Here's a little video of the arc comparison. So without point-of-wave technology, you can see this long, bright arcing, while with point-of-wave technology, it's a lot smaller. This is how it's saving those contact lives and reducing thermals. So once again, this is just closing and opening the contact as it crosses that 0 point on the current wave. So here's just another photo of showing your space savings of the M100 with the 0 stack and no derating. We are able to squeeze in an extra 4 motor starters without any additional space taking up. We actually save more space and include more motor starters compared to traditional contactors and overloads. There's a wide amperage range. This will reduce your number of SKUs. So for these skinny guys, they go from 0.7 amps up to 9 amps. So rather than buying a 2, a 3, an 8, and a 9 contactor, you just buy one. And for these guys, you have 4.6 amps up to 23 amps. Once again, a large reduction number of SKUs. So if you want a 5 amp contactor, 9 amp contactor, and 20 amp contactor, you can just buy 3 of these. And then you also need to train people less because they won't need to know the different wire gauges. Well, depending on your current through them, you should still follow wire gauge size, but it's about the same. So the key takeaway for the M100 electronic motor starters is adherence to SIL 3 PLE, which is one of the highest safety standards. This helps ensure the motor starts reliability in critical applications and improving overall safety of your system. The embedded safety features such as overload protection, phase loss detection, phase imbalance monitoring. This helps contribute to a comprehensive protective solution, and a 75% reduction in number of components required, a 56% reduction in wiring costs, and a 78% reduction in panel space. And then here's a list of additional resources. Thank you for your time. Does anyone have any questions?
I have a question. How do I communicate with this? How do I interact this with my control system?
So right now it's still going to need digital I/O. So this is controlled. So for this example, let me pin me. Spotlight. So here we have 2-button control. So if you have a control logics, you're going to need a digital input-output card in order to control this. So digital in 1, this is going to be essentially a safety feature. If this loses power, then it's going to turn off. And then in 2 is going to be like a toggle. So this is just sending one pulse to in 2, and that's toggling on. When I press this red button, it's cutting power to in 1. So then the M100 is turning off. If I wanted to see on my PLC if this is running or the overload is blown, I use O1 and O2. These would be outputs back to your PLC. And then this guy right here, if I have another output channel on my PLC, I can use it to remotely reset the M100. However, if I turn the M100 on and the overload blows, I believe if I hold it to 5, it'll simulate. So now it's simulating a blown overload. I can't just press start again. I'm going to have to hit stop and then start. That includes for remote reset. So I will need to send I'll need to send a stop signal to the M100. Then I can send a reset signal, and then I can hit start, and my M100 will turn back on. We have a lot more data about this. If you are interested in more details, I can send you an email and answer any other questions you might have.
All right, thank you.
Does anyone else have questions? If you guys are interested, I do have a longer presentation where I go through more technical points of the M100.
Thank you very much.
Yeah, thank you, Peter.
Thanks very much, Peter.